Hey everyone, and welcome to today's Explainer. I am so excited you're tuning in. Today, we're stepping right into the fascinating world of physics to uncover exactly how energy moves, shifts, and changes all around us. So, think of me as your digital classroom teacher for the next few minutes. We're going to look at the invisible forces that literally allow you to walk, talk, and even power the very device you're using to watch this right now. Honestly, by the time we're done here, you're going to see the world completely differently. Let's just jump right in.
Here's our digital whiteboard for today. We'll be covering the golden rule of energy, everyday energy transformations, powering our modern world, the big misconception, and we'll wrap it all up with a quick lesson summary.
All right, section 1, the golden rule of energy. Let's dive into this.
Before we get into how energy powers whole cities, we really need to understand the fundamental building blocks of what energy actually is. Basically, energy is just the ability to do some sort of useful work. You and I, we need energy for the absolute most basic daily tasks, walking across a room, talking to a friend, or just keeping our hearts beating. But where do we get it? Well, we eat. Food contains chemical energy. And once our bodies digest that food, that chemical energy makes us capable of doing work. Without that chemical energy stored up from your meals, you simply wouldn't be able to speak or walk. It's the fuel for the human machine. Now, pay super close attention here, because this is a massive, highly important point. If you're a note taker, definitely write this down. This is the law of conservation of energy, and it gives us 3 absolute universal rules we always have to follow. Point 1, energy can never be created or destroyed, no exceptions. Point 2, it can, however, be transformed or transferred from one form into another. And point 3, the total amount of energy always remains constant. Basically, the universe operates on a very strict energy budget. Let's ground this rule in reality, just to see exactly how it works. Take the number 105. Imagine you eat a banana that contains exactly 105 joules of chemical energy. When you eat it, your body doesn't magically create new energy, and it definitely doesn't destroy what was in the banana. Instead, when you start walking, your body perfectly converts that exact 105 joules of chemical energy into 105 joules of kinetic energy, which is the energy of motion. The total amount stayed exactly the same, perfectly conserved with zero waste. It just shifted from chemical right into kinetic.
Moving on to section 2, everyday energy transformations.
Okay, so now that we know the ground rules, let's apply them to the incredible energy chains happening out in nature, and frankly, in our daily lives. The whole shebang starts with nature's ultimate power plant, the sun. In step 1, the sun blasts out light energy. Then step 2, plants take that light energy and transform it. They basically store it as chemical energy. And finally, step 3, when animals eat those plants, they digest them and take on that chemical energy. The animal then transforms it yet again into other useful forms: sound energy when they make noise, heat energy to stay warm, and kinetic energy to run around. It's just this continuous, beautiful chain of transformations.
And the exact same rules apply to our machines. Take a car engine, for example. Let's say you have a bottle of fuel containing exactly 10 joules of chemical energy. When we pump this fuel into a car's tank, the car starts moving forward, right? Well, under the hood, the car has flawlessly transformed those 10 joules of chemical energy into exactly 10 joules of kinetic energy to propel itself down the road. Again, no energy was created, none was destroyed. It was simply transformed into forward motion. Let's visualize another classic physics example. Think about a dropping ball. When you hold a ball up at a certain height, it possesses what we call potential energy. Basically, it's stored energy just waiting to be unleashed. The split second it starts falling, that potential energy dynamically morphs right into kinetic energy. But what happens when it smashes into the ground? Does that kinetic energy just vanish? No way! It instantly transforms into sound energy, that loud smack you hear, and a little bit of heat energy from the friction of the impact.
Let's scale this up. Section 3, powering our modern world. So, we're escalating from simple daily examples to the advanced engineering concepts that actually keep our cities running. Think about those massive wind turbines you see on the side of the highway. How do they actually work? Well, it's just a series of energy transformations. Step 1, the wind blows. That is pure kinetic energy. Step 2, the giant turbines capture that kinetic energy and convert it into mechanical and then electrical energy. Fun fact for you, just one single rotation of a massive modern turbine can provide enough electrical energy to power an entire house for a whole day. Wild, right? Finally, step 3,
That electricity travels to your home, where your appliances transform it yet again into light energy for your lamps, sound for your speakers, or heat for your oven.
We see the exact same logic with hydroelectricity, which is power generated by moving water. Step 1, water gets stored in large dams or reserves at a certain height. Because it's up high, it holds massive amounts of potential energy. Step 2, as that water is released and plummets downward, that potential energy converts into heavy, rushing kinetic energy. And step 3, this violently falling water runs through turbines, spinning them incredibly fast and transforming that kinetic energy straight into electrical energy to power thousands of homes. And of course, we can't forget solar energy, a cheap, powerful source of energy straight from the sun. The whole process starts with sunlight. To make it useful for our electronics, we use these semiconductor devices called solar cells. But here's a really essential engineering detail. To get a sufficient amount of voltage out of them, we actually have to connect these solar cells in a series, which forms a solar panel. That panel converts the solar energy into electrical energy, which then powers the devices in your home, eventually becoming kinetic, sound, or light energy.
All right, Section 4, the big misconception.
We're approaching the climax of our explainer today, and it is time to bust a very common pitfall that trips up so many people on physics exams. Let's pause for a second and genuinely think about this. Are energy transfer and energy transformation exactly the same thing? Because people use these words interchangeably all the time in casual conversation, right? But in physics, they mean completely different things. The distinction here is absolutely crucial. Energy transfer simply refers to the movement of energy from one location to another. Think about plugging your phone charger into a wall socket. The electrical energy flows from the socket, through the wire, and into your electronics. It stayed electrical energy the whole time. It just moved places. That's a transfer. Now, energy transformation means changing energy from one type to another type entirely. Like when you eat fruit and digest it, your body changes that chemical energy into kinetic energy so you can move. The type of energy completely changed, and that is a transformation.
Which brings us to Section 5. Quick lesson summary.
Time flies when we're learning, right? Just like a masterclass teacher wrapping things up before the bell rings, it is time for a rapid-fire revision to firmly lock in everything we've covered today. First, the conservation law. The total amount of energy always remains constant. It cannot be created or destroyed. Remember our example? 105 joules of food energy becoming exactly 105 joules of kinetic energy. Second, transfer. This just means energy moves location, like electricity traveling from a wall socket through a wire to your charger. And third, transformation. This is when energy actually changes its type entirely. Think solar panels turning sunlight into electrical power, or a falling ball turning potential energy into kinetic energy. So I want to leave you with this one provocative question to chew on. What invisible energy transformations are powering your body right now as you watch this explainer? Seriously, think about it. The chemical energy from your last meal is turning into the heat keeping you warm, and the kinetic energy moving your eyes across the screen. Physics is happening inside you and all around you, every single second. Thank you so much for joining me today to explore the rules of energy. Keep observing the world, keep asking those big questions, and I will see you on the next explainer.